Hey there, tech enthusiasts. Welcome back to Bazai, your go-to channel for mastering cloud-native technologies. If you're working with Kubernetes and want to nail your scaling game, you're in the right place. Today, we're diving deep into the top Kubernetes scaling strategies you must know. I'm breaking down the 4 most powerful strategies: horizontal pod autoscaling, vertical pod autoscaling, cluster autoscaling, and predictive autoscaling. Grab your kubectl and let's roll. Horizontal pod autoscaling, HPA. Scale out like a boss. HPA is the most common strategy and your first defense against fluctuating demand. It automatically adjusts the number of pod replicas in a deployment, stateful set, or replica set based on real-time metrics. How it works: it queries the metrics server via Kubernetes Metrics API for metrics like CPU or memory. 2. Vertical pod autoscaling, VPA. Give your pods a power-up. VPA doesn't add more pods. Instead, it adjusts the resource requests and limits, CPU memory, for existing pods based on real-time usage. Mechanism: monitors usage with metrics server. Suggests optimal resource allocations. Triggers a pod eviction plus rescheduling to apply the new resources. Example: VPA might bump a pod's CPU from 500 M to 1 core if it's consistently maxing out. Deal 4. Stateful apps like databases. Apps where horizontal scaling isn't feasible. Downsides: rescheduling equals potential downtime. Use disruption budgets or run during off-peak hours. If your CPU usage is at 80% and your target is 50%, HPA will scale up the number of pods proportionally. Grade 4. Stateless applications. Burst workloads. Keeping response times low under load. 3. Cluster autoscaling. Scale the infrastructure, not just pods. Cluster autoscaler operates at the node level. When your pods are pending because there's not enough compute, it provisions new nodes. How it works: detects unschedulable pods. Talks to your cloud provider, AWS, GCP, Azure. Requests and adds nodes via the cluster API. Also deallocates idle nodes when demand drops. Example: a spike in video transcoding jobs creates pending pods. Cluster autoscaler boots up new GPU nodes. Best 4. Dynamic, unpredictable workloads. Cost optimization via on-demand scaling. Watch out for provisioning delay. Preemptive scaling plus warm pools can help reduce cold start lag. 4. Predictive autoscaling. Scale before the storm. The most advanced method, predictive autoscaling, uses machine learning to forecast future load and scale proactively. What it does: analyzes historical usage patterns, predicts spikes, e.g. Black Friday nightly batch jobs, works with autoscalers like Kada or custom ML pipelines to pre-scale pods or nodes before traffic hits. Example: your analytics service sees traffic spike every day at 9 a.m. Predictive scaling kicks in at 8:55 a.m., smooth as butter. Ideal for mission-critical systems. Traffic with known patterns. Challenges: requires quality historical data and well-trained ML models.